All right, so we're going to take what we did in example 2, and now we're going to perform the same hypothesis test, but using our p-value method. All right, now, if we were using that method from the very top, rather than already having this information already done, we would not have looked up this critical value. We would have instead simply done our test statistic and got 5.34 and compared our p-value to the 0.01 that was alpha. All right, but 5.34, as we are going to see, if you remember from your original normal charts, 5.34 is probably off of those charts, probably not even on those charts, meaning anything to the right of 5.34 is going to be very, very small. And probably when we put it into StatCrunch here in a minute, it's going to give us 1. Remember that we're looking for the area to the right, though, which is going to be a very, very tiny amount. Okay, so let's go to our stat track. And here we go. And let's put in 5.34. And remember, this is going to give us the area to the left. And this must be exactly one blank. Oh, I must not have fully erased things here. Let's try that again. All right, now calculate. And of course, it is saying that that probability is 1. Now, it's not really 1. It just means that the probability is very, very close to 1. And when we subtract it, because we want the area to the right, it means our probability is very close to 0. So the p-value here, we are unable to calculate how very tiny it is with this StatTrack software. So what we've got to do is say that our p-value is 0.000. Right? So it's the area to the right of that 1. It's very, very tiny. It could be something like 0.000006, just very, very small. So all it can do is give us that the area to the left of 5.34 is 1, when in fact it might be 0.999994 or something like that. All right, so our p-value we're going to state as 0.000. It is smaller than alpha. So remember, when the p-value is smaller than alpha, we still reject the null hypothesis. And in truth, the rest of this remains the same, except we say there is significant evidence and state our p-value, which is stronger than alpha, to reject the null hypothesis. Company 1 has a higher mean satisfaction rating than Company 2. Now, a good piece of software would actually be able to give us that p-value out to whatever many decimal places it takes to actually have something other than 0. But we have to deal with the free software that we have here.